was, all right, the last thing that we need to talk about is graphing solutions to systems of linear inequalities. Okay, so we're going to take a little bit of what we learned in the first video about graphing lines, and then what we learned in the second video about graphing linear inequalities. And we're just going to put it together and see what happens. Okay, so I'm going to come up with a couple of linear inequalities for us. First, I think we'll use y is greater than x. We actually saw that inequality in the last video. Then I think we'll use, I don't know, y is less than or equal to 2 times x plus 1. How about that? So what we're going to do is first we'll graph this linear inequality, and then we'll graph this linear inequality, and we'll look at the place where the solution sets overlap. And that is our solution space for the system. Okay? Let's get started. All right. So, using the t-table method, I'm going to first graph the line representing actually y is equal to x. Okay? So, considering y is equal to x, if we plug in 0 for x and figure out what y would be in this case, we'll discover that y would also be equal to 0, because this is just the simple inequality y is identically equal to x. Then we'll consider what happens when x is equal to 3. Well, here that would mean y is equal to 3 as well. 2 points make a line. Let's throw it on a Cartesian plane. Okay. Recognizing that this entry corresponds to the point 0, 0, and recognizing that this set of entries represents the point 3, 3, we'll go ahead and plot those 2 points. Well, 0, 0, we know that's the origin. Let's put that right there. And 3, 3, well, we walk over 3, walk up 3, and I'd say that point is probably about there. Now let's draw a line through it. And we recognize that the real thing we're trying to graph is this strict inequality. And since there's no potential for equality, that means that this line better be dashed. So I'm going to grab my eraser and just kind of erase just a little bit of that line, just to give me a dashed line, which is what we want. Now we want a test point to determine whether we want to shade above or below the line. I'm going to choose the point, I don't know, maybe 2, 0. Okay? So I'm going to use this point 2, 0 down here as my test point. So what I do with the test point is I plug that in to the inequality and I verify the truth value of the statement. So I say 2, 0. If I plug those 2 numbers into this linear inequality, am I going to end up with a true statement? Well, let's see. X over here would be 2. Y over here would be 0. I need to make sure that I use the same inequality symbol in between those 2 numbers. And now I ask myself, is it true that 0 is greater than 2? Well, no. Not in any mathematics I've ever learned. That is not true. So I know that whichever side of the line I shade, I better not pick up that point in my solution set. In other words, I'm going to shade over here. And this is similar to the last video. That's how we shaded before. Okay, so now I have graphed the solution to the linear inequality y is greater than x. All right. Well, let's go ahead and graph this inequality too and see what happens. Okay. So I'm going to go ahead and use the t-table again. So I'm going to choose a couple of values for x and see what would happen to y in that case. All right. But again, I'm not going to consider the inequality right away. First, I'm going to think of the line y is equal to 2x plus 1, okay? So maybe I'll jot that down right here. Consider y is identically equal to 2x plus 1. That's going to give us our points to create our line to get started graphing the solution set to the linear inequality. Okay, so pick a couple of values for x. I don't know, maybe 1 and negative 1. The choice is up to you. Okay, so if I want to graph this line, y is equal to 2x plus 1, I'm first going to think, what happens when x is equal to 1? Plug that in. Okay. So if I plug in 1, I have y is equal to 2 times 1 plus 1. Well, 2 times 1 is 2, plus 1, that's 3. So I see that in this case, y would be equal to 3. I take that 3 and I plug it into my t-table, recognizing that this pair of entries corresponds to the point 1, 3. Okay? Now I'm going to figure out what would happen to this equation if I plug in x is equal to negative 1. Okay, so I'm just going to plug it in. 2 times negative 1 plus 1. Well, 2 times negative 1, that's negative 2. Add 1 to that and I get negative 1. So in this case, I would have y is equal to negative 1. Now I'm going to take that and I'm going to plug it into my t-table. And I'm going to recognize that these entries right here correspond to the point negative 1, negative 1. All right. Well, 2 points make a line. So I'm going to go ahead and I'm going to graph these 2 points. Let's see. First I have the point 1, 3. So I'm going to walk over 1 and up 1, 2, 3. So there's 1 point that corresponds to that line. Now the second point, negative 1, negative 1, I'm going to walk to the left 1 point and down 1 point. So got something like that. 2 points make a line. I'm going to try to construct a line through those 2 points there. And I'm going to have something that looks a little bit like that. Now, this time I'm trying to figure out the solution set to this y is less than or equal to 2x plus 1. Well, since I have the potential for equals to, I'm going to need a solid line. So I don't have to erase parts of that line to make it look like it's dashed. I'm just going to leave it up there like that. Next, I need to find a test point again. Now remember, the test point has to be a point that's not on the line. So, I don't know, what do you like? Maybe I'll take that 2, 0 again and just see what happens, okay? So my test point, this time I plug that test point into my second inequality. So I would say, okay, 2, 0, that would mean that I plug in 0 where y used to be. And I plug in 2 where x used to be. So now I have the statement 0 is less than or equal to 2 times 2 plus 1. Well, 2 times 2 is 4, plus 1, that's 5. And I have this statement 0 is less than or equal to 5. Is that true? Yeah, 0 is less than 5, so I call that a true statement. So now for this line, I need to shade on this side of the line that we've graphed, okay? So I know that this point is part of a solution set, so when I do my shading, I need to shade on the side that's going to pick up that point. So I would shade like that. So now I've graphed my first linear inequality, I've graphed my second linear inequality, and I see that my solution set is this space right here. It's where the red shading overlaps with the blue shading, okay? So my final answer here, if I were to graph the solution set, it would be these 2 lines and the shading that we see over here. in between them. And that's the method we use. What I do when I have these kinds of problems is then I'll erase this extra shading so that my teacher knows exactly what it is that I'm trying to represent, okay? Precision is important because it's your job to communicate with me what it is that you know, and it's my job to make sure I can read it. So I'm going to tell you that part, but I hope this helps. Please, if you have any additional questions, feel free to email me. I'll get to them as soon as I possibly can. Thank you.